Hope you are preparing well. These are some must-do questions before you are going to your examination. These questions include organic, inorganic, and physical. Let's see the first question. Let's check how well you have prepared to your examination. First question says, what amount of bromine will be required to convert 6 grams of phenol into tribromophenol, ortho and para-substituted phenol? So let's see how much is required. 6 grams of phenol. So what is the molecular weight? 130 degrees Celsius forming Y. Then that is producing phenol plus Z. They are asking X and Z in the reaction. So this is an important preparation, industrial preparation of phenol. Right? So let me write the reaction. The first step is Friedel-Crafts alkylation, so which will give you benzene with CH3, CH double bond CH2. That will give you this part, isopropyl benzene, right? So which is also called as cumene. From that, it is giving you, in the presence of oxygen, it will form cumene peroxide. Cumene peroxide, and after that it will reacted with what we have over here, that is H2O, heat, to produce phenol. The byproduct is also important in this reaction, which is nothing but acetone. Right? So answer will be isopropyl benzene, that is X. Y is cumene peroxide. They are asking Z, that is acetone. So A is your correct answer. Then which of the following reactions is giving tertiary amine is obtained? Okay. Aniline with CH3I. Okay, once again I am treating it with CH3I. Then the option B says aniline with CH3I. And option C is nitrobenzene with tin HCl. Nitrobenzene, that will give you primary amine only, none of these. Okay, so the first one, here I am treating it with aniline. So what that will give? C6H5NH CH3. HI will get eliminated. Correct? So again I am treating it with methyl iodide, which will give you C6H5N CH3CH3. HI will get eliminated. So this will give you tertiary amine. But in case of this only give this product. Correct? That is a secondary amine. Here that will give you primary amine only, that is C6H5. Not a primary amine, it's an aryl thing. That is C6H5 and H2, aniline is formed. So option A would be your right answer. Then halogen compound X, C4H9Br on hydrolysis gave alcohol Y. The alcohol Y undergoes dehydration with 20% H3PO4 at 358 Kelvin. What is X? Okay. So first of all, we have C4H9Br with H2O. That is giving us alcohol. So what type of alcohol we can expect? What that will do with the presence of H2O? C4H9OH with HBr, that would be formed. Corresponding alcohol that has been formed. Okay. Let's see the options. Before that, we have another thing, right? So alcohol Y is undergoes dehydration with 20% of H3PO4. Okay. Why that alcohol? It is a mild dehydrating agent, H3PO4. So which will undergoes dehydration. So dehydration is favored by what kind of alcohols? So first of all, tertiary alcohol, then comes secondary, and then primary, and nothing. Don't worry about other things. Right, tertiary takes place first. Okay, because the easy dehydration in this mild condition is a tertiary one. So among these, which is tertiary? This is primary, this is tertiary, this is secondary, and this is primary. So option B would be your right answer. Upon dehydration, let me write the reaction as well if you want. So CH3 thrice Br is there. So C4 H9, is it sorted? Br, yes. So which is undergoing reaction with H2O? That will form CH3, 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 OH, HBr. With this, dehydration will happen to produce CH3, double bond CH2, another side CH3. Right? Okay, so this is your product. Then identify A and B from the following reaction. So let me give you the reactions first. So the first reaction, that is CH3, CH double bond CH, CH3, which is undergoing O3 with zinc H2O, that is forming 2X. The second reaction says 2X is treated with NaOH and heat, which is forming Z. It is undergoing osmolysis to produce A plus B. They are asking A plus B of this reaction. Okay. So let's see one by one. First of all, this is butene to butene. Upon osmolysis, what that will give? I'm writing the product over here. Upon osmolysis, what that will give? Break the double bond, put double bond O. Correct? So CH3, C double bond O, H, plus another side also CH3, CHO. The 2 moles of X has been formed, that is acetaldehyde. Then with NaOH and heat, acetaldehyde is undergoing NaOH and heat to produce Z. What is this reaction? 2 moles of acetaldehyde in the presence of base. If you know what this reaction is, it is a condensation reaction. In the presence of, I can give you the clue point, it will happen only presence of alpha hydrogen containing compounds. Tell me in the comments what is this reaction, name reaction is called. So Z will be CH3, CH, the condensed product will be formed CHO. Upon osmolysis, it is forming A and B. So here I am having the double bond. So break the double bond, put double bond O. So CHC, CHO plus CHO, CHO. What is this? Chlyoxal, right? So this is our product, acetaldehyde and chlyoxal. We have the options. Acetaldehyde and chlyoxal. Okay, this is a bond. So this is your answer. The next question is, fluorobenzene can be synthesized in the laboratory by heating phenol with HF and KF, by direct fluorination of benzene with F2 gas, from aniline by diazotation followed by heating the diazonium salt with HbF4 by reacting bromobenzene with NaF solution. Okay, so the first one, you can take HF is a weak acid. Reaction is not feasible under normal conditions, so this will not happen. Then the second one, direct fluorination of benzene with F2 gas. F2 gas is extremely reactive, that we know would cause the very bad side effects, reactions, right? So this will also be not possible. And from aniline by diazotation followed by heating of diazonium salts with HbF4, which is a Ball-Schiemann reaction. Do you remember? And the last one is bromobenzene with NaF solution. So this is nucleophilic substitution on aryl halide. Not directly it will give the fluorobenzene. So this is also not feasible. So option C is your right answer. Then the boiling point of 3 isomeric pentanes follows the order N-pentane, isopentane and then neopentane. Statement 2 is, when branching increases, the molecule attains a shape closer to the sphere. This results in smaller surface area for contact, due to which the intermolecular forces between the spherical molecules are weak, thereby lowering the boiling point. So the option is saying about which of the statement is right and which that explains it. Okay. So let's analyze it. N-pentane, isopentane and neopentane. Neopentane is highly branched and spherical, right, which is having 4 CH3 groups, and in case of isopentane it is having a 1 branch, and N-pentane is a linear thing. Okay, so by comparing the boiling point difference depend on the space arrangement, branching, the boiling point is right. N-pentane will be highest, then comes iso, then comes neo. So statement 1 is right. What about statement 2? Branching increases means what will happen? The molecule become more and more compact, right? The spherical molecules have less surface area of contact. So reduced surface area of contact, that will weaken the van der Waals forces. So statement 2 is also right. So which tells us option, both the statements are correct. Statement 2 explains the statement 1. Then C2 is rotated anti-clockwise 120 degree about C2-C3 bond. So they are asking about this configuration. This is our question. Okay, so this is C2 and this is C3. So when we are rotating anti-clockwise of this conformation, what will you get? What is the conformer you will be getting? So first of all, this is an anti-position, most stable position of butane, correct? So upon rotating it to 120 degree, so what will happen? First, let's rotate it to 60 degree. So what will happen? In the anti-clockwise, which will be going in the way CH3, H, H, CH3, H and H. This is 60 degree. So another 60 degree I am going to rotate. From this another 60 degree to anti-clockwise. So which will be producing this is, to be more precise, this is occupies the center, H, 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 H. Okay, so this is what a conformation I'm getting. So what is the name of this conformation? CH3, CH3 is nearer to each other, so which makes it Gauge conformation. Okay. Then moving on to the next question. Oxygen and sulfur both are members of the same group in periodic table, but H2O is liquid while H2S is gas. Because, okay, so the options given as H2S is a weak acid, molecular weight of water is more, electronegativity of sulfur is more, water molecules are having weak hydrogen bonds between them. Okay, so here you can see molecular weight of water is more. That is not possible. Molecular weight of water is 18. Here the sulfur is more. So that won't be our answer. Comparing the statement D, water which is having the weak hydrogen bonds between them, that is true. H2S is a weak acid, but it is not explaining the physical state of difference, and it is not the primary reason. And electronegativity of sulfur is more, that is also not true. So option D is your right answer. A quick heads up to you guys, if your siblings or your friends studying the next year JEE or NEET, or even for the board exams, any chemistry related program they are going, the admission is open on ChemCrack. The link is in the description. You can click on it and register. We are having courses for 2026 and 2027 as well. So please join early to grab your offers. Okay, let's see this question. CH3CH2I with KCl, that is giving you X. X is undergoing hydrolysis to produce Y. Y is undergoing again hydrolysis to produce Z. So what is Z? That is our question. So first what that will give, CH3CH2I with KCl, that will produce CH3CH2Cl. Correct? Just a substitution. It is undergoing hydrolysis. First that will give you CH3CH2 C double bond O NH2. Then again this will give you CH, upon hydrolysis it will give you CH2 COOH, along with that ammonia will get released, right? So answer to this question is propanoic acid. Okay, butane 2-one can be converted to propanoic acid by which of the following? Butane 2-one, okay, converted to propanoic acid by which? Okay, this is a clearly oxidation reaction. Fine. So ketone is there, so no other way to go for Fellings or Tollens reagent. I don't think this will react. This is not at all a good reagent to do this kind of oxidation. So this is a haloform, or more precise iodoform reaction, which will form one of those carbon will become iodoform CHI3, and remaining thing will get oxidized to form the salt of acid, salt of the acid. So option C is your right answer. Which of the following alcohols is dehydrated most readily with concentrated sulfuric acid? Okay, CHOH CH3 to the benzene ring, which is attached with the para-methoxybenzene ring, and para-nitrobenzene ring, para-chlorobenzene ring. Okay, so which of the following alcohols dehydrated most? So dehydration of these alcohols in the presence of concentrated sulfuric acid is following E1 mechanism. Correct? These the given alcohols are secondary, so E1 is quite possible. So the rate will depend on carbocation stability only. So let's analyze the carbocation stability. The first one, which is attached to benzene ring. So benzylic carbocation, it will be form CH, so it will be gone, so remaining CH3. So another thing is para-methoxybenzene ring. Again, then the third option says para-nitro, same kind of carbocation, and final one is para-chlorobenzene ring. Okay, so now we have to determine which substitution influence the most. Okay, the first one, which is not at all having any substituent, that is having baseline stability, let's compare it with others. Okay, so para-methoxy 1, it is a strong electron donating group, so it is showing the plus M effect, and nitro group is again once again strong electron withdrawing group is there and showing minus M effect. So in case of option D, weak electron withdrawing group is there, Cl. Doing this, so the carbocation stability will be more for strong electron donating. Okay, so it will be going in the order B comes first, and then A, D, and then C. So answer to this question is B. The next question is the major product obtained in the following reaction is. Okay, here I am having CHO and another carbonyl group. Okay. With NaOH, with heat, what that will give? These are the options given. Okay. So by seeing this reaction, you must have understood this is undergoing intramolecular alcohol. Correct? So how it happens? Let me take the reagent first, reactant first. So which is having a CHO group, and another side I'm having another carbonyls group, CH3CO. Now as a first step, what that will do? Enolate formation, correct? So the alpha hydrogen position, I'm having hydrogens, so that will get removed to form a enolate. So how that will look like? 2, 3, here I'm having C minus with this, correct? 1, 2, 3, 4, 1, 2, 3, 4, correct? So then check for any ring formation is there, because in the options it is shown that rings are also possible. So what that can do is, this part is giving you the ring formation when it is attacking the CHO. Due to that, it is forming the ring. How many membered ring? 1, 2, 3, 4, 5 membered ring. So 5 membered ring. In the fifth position, let's say this is fifth position. Fifth position, I'm having double bond O CH3, and in the first position, I'm having O minus, because here it must have formed a something like this, correct? Now O minus is there, and anything I missed? In the second position, I'm having one CH3. Okay, then after that, what will happen? H2O participation. Due to that 5 membered ring, O minus will take up H plus to form OH. So that OH and less acidic, what are the hydrogens possibly can get eliminated? So I would like to change it a bit. It is also fine. Here I'm having one hydrogen and another hydrogen that can have from here. So comparing these two, which will be more acidic? Obviously, with the double bond O hydrogen, this is more acidic, which undergoes beta elimination to form a product of OH will get eliminated over here. So remaining, I'm having CH3 double bond, because this is got eliminated. With the double bond, I'm having double bond O CH3. Right? Let's check with the options. Option C matches your answer. You can see, as you can see, CH3 CO double bond and CH3 same as this. So option C is your right answer. Moving on to the next question. End product in the above sequence of reaction is. The sequence is simple: C6H5, COCl with NH3 is producing X. X upon reaction with P2O5 giving Y. Y with nickel hydrogen producing Z. They are asking about Z. So first, what that will do with ammonia, it will produce C6H5 CONH2. H will be taking up one Cl. Then that is our X with P2O5. P2O5 is a good dehydrating agent, so which will lead to the formation of cyanide or nitrile. C6H5 Cl. With nickel hydrogen, again hydrogenation or reduction, this will give you C6H5 CH2 NH2, that is benzyl amine. Correct? Moving on to the next one. Consider the following reactions with the tertiary alkene 1 and 2 are respectively. Next question. Consider the following reaction with tertiary alkene 1 and 2 are respectively. Here you can see alkene is reacted to form different type of alcohols. So one is attached with less substituted one and another one with less substituted one and more substituted one. Those two are the product formed. So let's take out the options as well. Hydroboration, oxidation, acid hydrolysis, oxymercuration, demercuration. That is the overall option says. Let's see the first one, which is undergoing OH2 more substituted carbon, which is an Markovnikov product. And this side is forming anti-Markovnikov, right? So which means oxymercuration, demercuration is giving you Markovnikov, and hydroboration followed by oxidation, that will give you anti-Markovnikov. So one will be our oxymercuration and demercuration, and 2 is hydroboration followed by oxidation. Then the next question, complete the following reactions. 8NH3 plus Cl2, which is giving excess of NH3, which is giving 1, where the NH3 is excess, and the second reaction is NH3 with 3 Cl2 in excess of Cl2, that is forming the product 2. Okay, what is product 1, what is product 2, that is our question. So in the presence of more amount of NH3, it will act as a reducing agent. So which makes, so there are two scenarios, excess of NH3 and excess of Cl2. So excess of NH3, this will act as a reducing agent, so where the Cl2 is getting reduced and ammonia is getting oxidized. Ammonia makes Cl2 to HCl and get oxidized to N2 to HCl. So let's check out the options where I'm having Cl2 to HCl and N2. Okay, the option A is there, and option C also I'm having N2. Option D is also option D, I don't have N2. So either option A or D. Let's analyze the next scenario, excess of Cl2. In excess of Cl2, it acts as a oxidizing agent where ammonia gets chlorinated to form NCl3. Right, the reaction goes like this. Ammonia plus 3Cl2 forms NCl3 plus 3 HCl. Okay, so let's check with the options. NCl3 with HCl, option A need to be your right answer. Then decreasing oxidizing ability of the halogens in the aqueous solution down the group is evident from. So analyzing the oxidation states, all halogens in X2 form an oxidation state of 0. Right? In X2 state, all the oxidation states of 0, and all halides are able to form -1 oxidation state. So that didn't explains the trend. So the decrease in oxidizing ability of halogens like fluorine and then bromine and then iodine is from electrode potentials only, because fluorine F2 to F minus electrode potential is plus 2.87, and then it is getting Cl2, it's getting decreased, then comes Br, that is also less, iodine is 0.54. So standard electrode potential is your answer. Then where A and B in the following reaction is NaOH with SO2, A and H2O is formed, B plus H2O and SO2, it is forming sodium bisulfate. So NaOH with SO2, it is basically a acid-base reaction, because SO2 is an acid or acidic oxide, right? So what that will do, SO2 plus OH minus from NaOH, it will give you SO3 2 minus plus H2O. So in the options you can see SO2 2 minus, which is Na2SO3. That is there in option A also, option C also. Let's analyze to B1. B plus H2O and SO2 to form sodium bisulfate. To form 2 sodium bisulfate, B should have a 2 sodium. and remaining 2 SO3s are there. So B must be Na2SO3 plus H2O, that is forming SO2 plus SO2, that will form 2NaHSO3. By balancing also you can go about this one. So option A need to be the correct order of boiling point of the following compounds. The correct order of boiling points of the following compounds. So in these compounds HF, NH3 and H2O, there will be a hydrogen bonding presence, right? So what hydrogen bonding will do? That will increase the boiling point. So we have to analyze how well the bonding is strongest. So in case of H2O, that is having strongest hydrogen bonding network. Each molecule is having 4 hydrogen bonds. In case of HF, that is also having a hydrogen bonding, fluorine is more electronegative. It forms a linear chain. And in case of ammonia, it is having weak hydrogen bonding. So comparing H2O and HF, ammonia is neglected, that will be of least boiling point. So B or C must be your answer. Comparing H2O and HF, HF is forming a linear chain, H2O is having a log. So HF will have less and H2O will have more. So your option will be C, H2O, then comes HF, then N. Large number of oxidation states are exhibited by the actinides, then the lanthanides, the main reason being. Okay, the options A says more reactive nature of actinides than lanthanides. 4f orbitals are more diffused. Lesser energy difference of 4f and 16. More energy difference between 5f and 16. Okay. So first statement says that is reactivity. Reactivity is a consequence. It's not a main reason for this large number of oxidation states. So option A is not correct. Then option B, 5f orbitals are more diffused than the 4f orbitals. Correct. So this, which is also not correct. Then option C speaks smaller energy difference allows more electrons to participate in the bonding. That is true. And option D, it's contradictory of option C, which is not correct. So option C is your answer. Correct contacts with the transition elements, which of the following statements is incorrect? In the highest oxidation states of first 5 transition elements, all the 4s and 3d electrons are used for bonding. And in the addition of normal oxidation state, the zero oxidation state is also shown by these elements in complexes. Okay, so checking the maximum oxidation states of first 5 transition elements, scandium to manganese, all the 4s and 5d electrons are used for bonding. This statement is right. We already know. And in option B says the addition of normal oxidation states. The zero oxidation state is also shown by these elements. Generally, the transition metals can show zero oxidation state when in case of carbonyl groups, right? Carbonyl ligand is there, then that would exhibit zero oxidation state. So this statement is also right. Then option C, in the highest oxidation state, the transition metals show basic character and form a cationic complex. It is showing an acidic character, not a basic character first of all. They are forming an anionic complex, right? Manganate, permanganate or dichromate. So they are forming an anionic complex, not cationic thing, and they are showing a acidic character. So this is an incorrect statement which can be our answer. Then option D, once the D5 configuration is exceeded, the tendency to involve all d electron decreases. Yeah. So after D5, the pairing energy will get increases, right? So it will be difficult to remove all the d electrons. That is true. So option C is your right answer. Then the next question, amount of oxalic acid present in the solution can be determined by its titration with KMnO4 in the presence of H2SO4. The titration gives unsatisfactory result when carried out in the presence of HCl. Why is it so? So first of all, first option says get oxidized by oxalic acid to chlorine. HCl is not getting oxidized by oxalic acid. Oxalic acid is a reducing agent by itself. Okay, so option A is not a right answer, not right reason. Then option B furnishes H plus ions in addition to those from oxalic acid. So the extra H plus ions would not cause any unsatisfactory result. So which is again the wrong option. Then reduces permanganate to Mn2 plus. HCl get oxidized by permanganate. Okay, consuming the titrate, which will give you the incorrect result. So which is our right answer? And option D says oxidizes oxalic acid to carbon dioxide and water. HCl does not oxidize oxalic acid. Again, I'm telling you, HCl is not strong enough to oxidize the agent. So which is not our right answer. Option C is your right answer. And also, if they're asking the question about why H2SO4 is preferred, then KMNO4 will not get oxidized. That would be the main reason, and it will not interfere the titration part. That's why we are using H2SO4. Calculate the magnitude of spin angular momentum of the electron. Okay. So calculating the spin angular momentum, we have a formula. S model is equal to H bar root of S into S plus 1. So for each electron, S value will be 1 by 2, right? So and also H bar, which is equal to H by 2 pi. So which the value is 1.55 into 10 to the power minus 34. So calculating S into S plus 1, I'm just substituting the value S into S plus 1. So 1 by 2 into 1 by 2 plus 1, which is equal to 3 by 2, that is 3 by 4. So root of 3 by 4, which is H by 2 pi, or you can put the value as well. I'm just maintaining root 3 by 2. So I'm adding the answer 1.055 into 10 to the power minus 34 into root 3 by 4, that is 0.866, which is equal to 9.13 into 10 to the power minus 34. Okay, moving on to the next question. Calculate the energy required for the process helium plus to helium 2 plus electron. Given ionization energy for the hydrogen atom in the ground state is this much. Okay, so what is happening over here? We are removing the electron from the second, this is a second ionization energy, right? He plus 2, removing one more electron. So hydrogen like atom, then this will become hydrogen like atom. So E will be Z square into E naught. So Z value, atomic number is 2 square into E naught is given as 2.18 into 10 to the power minus 18. So by multiplying this 4 into this value, we should be approximately 4 2s are 8. So 8, yes, it's there in the option C. Moving on to the next question. The sodium flame test has the characteristic yellow color due to the emission of wavelength of 589 nanometer. What is the mass equivalence of the one photon of this wavelength? Okay, so first of all, we know that E is equal to Hc by lambda. Lambda value is given as 539 nanometer. Okay, so let's substitute the value 6.626 into 10 to the power minus 34 into C is 3 into 10 to the power 8 divided by 589. It is given in nanometers. I'm converting into meters. Minus 9. So the E value, I'm getting it as 3.37 into 10 to the power minus 19 joules. So what is the mass equivalence of one photon? So for finding out the mass, we know the formula E is equal to mc square, right? So we already got the E value. So M is equal to E by C square. So E value, which is 3.37 into 10 to the power minus 19 divided by C square value is, let's say, 9 into 10 to the power 9 into 9. Okay, 8 into 8, 16. So overall it will become 3.75 into 10 to the power minus 36 kilogram. Let's check with the option. 36 kilogram. They will not give you this much flows, but be ready. Then the geometrical isomers of the complex, this is optically inactive. And statement 2 says both geometrical isomers of the complex is possessing an axis of symmetry. Okay. So first let's analyze this complex. MNH3 4 times Cl2, which is an octahedral complex, right? And it will have a two geometrical isomer, that is cis and trans. So this cis isomer can have a Cl. This is A4 B2 type, right? The Cl can be of opposite position, 180 degree angle, which will have a plane of symmetry. So this makes it optically inactive. So check for the axis of symmetry. This both the isomers cis and trans possesses axis of symmetry. So writing it like this. So both the isomers can possess axis of symmetry, right? So statement 1 is true, both the isomers are optically inactive, and statement 2 is also true, both possesses active axis of symmetry. So the right answer would be option A. Then the next question is, this is paramagnetic and Fe here, that is having 3 unpaired electrons. Okay, so first of all, let's have what is the oxidation state of Fe over here. So aqua and NO is there. NO is neutral, aqua is also neutral. So overall this will become 2 plus. So 2 plus is the oxidation state of Fe. So Fe 2 plus, which is 3d6 oxidation, 3d6 electronic configuration. And these are weak field ligand, so which can have not undergo the para. So 4 unpaired electrons are there, so this is paramagnetic. And Fe here, that is having 3 unpaired electrons, that is false. Here we are having 4 unpaired electrons. So statement 1 is true, 2 is false. Then identify the incorrect statement regarding the complex. Chromium amine complex. The complex involves D2sp3 hybridization and is octahedral in shape. D2sp3 hybridization. Okay, let's see, this is octahedral. So that will have +3 oxidation state. And amine here acting as a strong field ligand. Identify the incorrect statement regarding the complex. Chromium amine complex. Okay. Option 1 says the complex involves D2sp3 hybridization and is octahedral in shape. Yes, that is octahedral in shape. This is paramagnetic. So paramagnetic, what is the oxidation state of chromium over here? That is +3. Right, +3 in case of chromium, that will have T2G3 and Eg 0 anyway, right? So we should have a paramagnetic nature, and complex is an outer orbital complex. So D2sp3 is an inner orbital complex, it is not an outer orbital complex. So here I am having a vacancy, by it have to fill the another d orbital. So this is an incorrect statement, and complex gives white precipitate with silver nitrate solution. Here I am having Cl3 in the outer coordination sphere. Obviously that will give you the cloudy white precipitate with silver nitrate solution. That is also true. Calculate the EMF of the cell in which the following reaction takes place. So calculating EMF of the cell, what are the details given over here? Concentration of nickel and Ag+. So as an oxidation part, nickel is becoming nickel 2+, and reduction part, Ag is becoming, Ag+ is becoming Ag2. So E cell of the reaction is 1.05 volt. So number of electrons participated over here is 2. So E cell, which is equal to E naught cell minus RT by NF ln Q. Correct? Let's substitute the values. So for finding out Q, where I'm having nickel 2+ and silver plus. So I'm substituting the values 1.160 and 0.002 square, which will give you the Q value, that is 4 into 10 to the power 4. Okay, let's apply it to the Nernst equation over here. So E cell, which is equal to E naught cell, the value is given 1.05 and 0.0591 divided by N value is 2 into log 4 into 10 to the power 4. Upon calculating, I am getting 0.91 as my answer is there in the options as well. Okay. Moving on to the next question. Reduction potential of 4 elements P, Q, R, S are given. Decreasing order of reducing power. Okay. So reduction potential, how it is affecting the reducing power. So reduction potential, which is equal to reducing agent. Okay. How well it can reduce the potential. Okay, reducing agent. So the more positive value of reduction potential, that is indicating the weak reducing agent, and reducing power is inverse to reduction potential. So here the values are given. P is minus 2.90, Q is 0.34, R is 1.20, S is minus 76. Okay. Which is having more positive value? R is having more positive value. That will be having least reducing power, as I told you. So R need to be least. Then comes Q, then comes S and P. So option C. Which of the following equilibrium reactions are not Kp and Kc is not equal to? It's not equal. Okay. So here Kp, Kc not equal means we have to look upon delta N value. So delta Ng value, if that is equal, then Kp, Kc will be equal. So let's check the number of reactants and the number of products are equal or not. By seeing that, option C, here I am having C as a solid. So 1 is the reactant side and 2 in the product side, which makes option C as your right answer to this question, which is not having equal Kp, Kc value. Then organic compound undergoes first order decomposition. The time taken for the decomposition to 1/8 and 1/10 of its initial concentration are given. What is the value of this into 10? Okay. Let's calculate. So first of all, this is a first order reaction that is mentioned over there. So the first order reaction, ln A by A naught, which is equal to minus Kt, right? In terms of log means 10, we will be adding 2.303. First, let's calculate it for T 1 by 8. So log base 10 A naught of 8 by A naught, correct? Which is equal to K T 1 by 8 by 2.303. So by substituting the values, so A naught will get cancelled out. So remaining I'll be having 1 by 8 log 1 by 8 and this side KT. So log 1 by 8 value will be minus 0.9. Similarly, if I'm calculating it for T 1 by 10, I'm getting the value of minus 1. Minus 1 K T by 1 by 10, 2.303. That will be same. So what is the ratio they are asking? So 1 by 9 by 1, both are in minus. So 1 by 9 by 1, which is 1 by 0.1. 0.1 into 10. Okay, so the answer needs to be option A. So that's it for today. Do more and more practice questions. Let us know if you have any doubts. The admission is open. Please do register. Join our course. Class is going to start very soon. Thank you.